Hey, welcome back to the first course of Introduction to Computer Architecture. I'm going right now to teaching the first part one, the simple introduction to the computer architecture or machine organization, and a little more courses on machine instruction and assembly language programming. So in here we have our computer. This is our computer. This is our computer. Internal computer have is based for three parts. Our computer architecture is based for John von Neumann architecture. Our first part and second part. Our first part is CPU. CPU is the first part of our computer. Our second part is memory. Memory. Our third part is input and output ports. Input and outputs. This is our organizations of computer. So we have the CPU here, memory here, and input and output port here. CPU, memory, and input and output. So after we have this, we have the system bus. System bus connected for these peripherals, connected to memory, connected to input and output, connected to CPU, vice versa. So the one address of these ones, the one line bus will contain the address bus. And so the second one is data bus. And so for here is address bus and data bus. So here is data bus and address bus. This is the two wires connected between CPU and memory and output, memory and input and output, and the CPU and input and output. So this is the basic architecture of our machine instructions for non-embedded systems. So we're going to disassembling our CPU architecture. Internal CPU architecture, suppose we're going to have the 4 basics. The 4 basics internal CPU. The first basic is register. Internal CPU have the registers. We have the registers. For our second internal of our CPU, we have the area. We have the area. Area standard for arithmetic, logic, and unity. For our third is control unity. Control unity. See, control unity. After this one, we have the system bus on it. The system bus or interconnected bus that are connecting these 3 wires. Control unity, ALU, and registers. ALU and our registers. Our registers for internal our control unity. For internal our control unity, this is our CPU architecture. CPU architecture. This is our CPU architecture for internal control unity. CU standard for control unity. ALU standard for arithmetic logic unity. Arithmetic and logic unity. Logic unity. So for internal our CU, for internal control unity, for internal our control unity, this is our control unity, or even CU. CU for our abbreviation is CU, control unity. Control unity. This is internal bus. Internal bus connecting registers, ALU, and control unity. For internal control unity, for internal here our control unity, we have the sequences of logic. The sequences of logic. The sequences of logic is located here. Sequences SA. SA standard for SA. Sequences logic unity. Sequences logic unity. Sequences logic unity, or even sequences is here. Let's see, for our second here is control memory. Control memory. CM. Control memory. CM standard for CM for our control memory. Standard for control memory. Control memory. Control memory for C standard for control memory. After these ones, we have the sum devices of another parts for internal our control unit. This is control unit architecture. Control unit architecture. Control unit architecture. Our control unit architecture. So for these ones, for this down these ones, I'm gonna use the green. Down these ones. For these parts connecting the control memory and sequences logic is control unit registers and address is named control unit registers and address. This is our basic internal of control unity. This is our basic of computer architecture. So this is our basics of CPU architecture. For internal our CPU have a lot of more other things. Forever, I find the basic ones. Notifying for internal. So our next course is to define area, our area. Our next course to define our area. After we define the control unit, after the second, our second course we define the register. We define the registers. Registers, maybe I don't know if we can see here the area architecture. We can use the broad things. The area architecture. Our area architecture. Our area architecture have internal of 4 parts. This is area, arithmetic and logic unities. Arithmetic and logic unity. For internal our area. For internal area for here we have an accumulator. AC accumulator. This is our internal of arithmetic logic computer of our machines. We have the internal parts of accumulator. Internal accumulator. So we have here MK, multiple quotient. Multiple quotient will store the remainder of the sum computing. Store the remainder of sum computing. So this one is connected here for you internal our bus. For here we have an arithmetic controller. For here we have an arithmetic logic circuits. Arithmetic logic circuits. ALC arithmetic logic circuits. We hold data from accumulator, and so for multiple quotient, vice versa. For after internal arithmetic logic circuits, we restore the computing of this one into MBA. Memory buffer register. This is our structure organization of our area. Memory register will also send in the signal to another parts of our computer architecture. For our computer architecture, this is internal our area. For our computer architecture, this is our simple basics and the first introduction to computer architecture. For computer architecture, for our second video and our second course, I'm going to drill through internal disk organizations and internal disk memory, internal CPU, internal input memory. So after to do this, the simple more bits of our computer architecture, we're going to use how to program this our architecture, the programming our architecture of this program. We'll program this our architecture for low level code, high level code. Our next video, I will teach you to program this architecture like in your assembly code, in your machine instructions, and in your C code. If you want to learn more computer architecture, computer programming, computer science, engineering, architecture, and audio engineering, sound engineering, you should follow my channel. You should follow my channel. This is our first part, introduction to computer architecture. See you is a red sharp pass fit. See you.